Okay, here we're going to do some more trig stuff. This time we'll be doing tangent lines and horizontal tangents and stuff like that. So first one is find the normal or perpendicular to the tangent of the curve y equals the sine of x. So for everything you need an x and a y and a slope value. So for a slope value we'll take the derivative of sine, which is equal to cosine of x. So therefore our derivative at pi over 6 cos of pi over 6, which is radical 3 over 2. Y of pi over 6 is the sine of pi over 6, which is a half. So the equation of our normal is going to be the negative reciprocal of our slope value, so negative 2 over radical 3. So our normal line would be y minus a half equals negative 2 over radical 3 x minus pi over 6. Distribute the negative 2 over radical 3, so you get negative 2 over radical 3x plus 2 pi over 6 radical 3 plus a half. The 2 and the 6 cancel, I'm left with 3. So we get y equals negative 2 over radical 3x plus pi over 3 radical 3 plus a half. And that's good enough for me. Determine if this function has any determine if we have any horizontal tangents given the following function. So horizontal tangents, when we're taking tangents, we're taking slopes and derivatives, so therefore let's take the derivative of our function. So dy dx will be equal to 1 plus cosine of x. Horizontal tangents set our derivative equal to 0, so cosine of x is equal to 0. Solving for x, we get the cosine of x is equal to negative 1, so x equals pi. So we have an x value. Our y value is going to be plugging pi into this function here, so we get pi plus the sine of pi. Well, the sine of pi is 0, so you're just left with pi. And our slope value, well, since it's horizontal, our slope value is 0. So using point slope, we get y minus pi equals 0 times x minus pi. So this is gone, so you just move the pi over, you get y equals pi. And our last trig equation is horizontal tangents again, but the function is just a little bit more interesting. So again, horizontal tangents, we take derivatives. So derivative of this function here, derivative of 1/2 x is a half. Derivative of cosine is negative sine x. Since we want horizontal tangents, we set our derivative equal to 0. Oops. So we get the sine of x equals a half. So all students take calculus. We have pi over 6, and also sine is positive in the second quadrant, so that would be 5 pi over 6. We need a function value. So y of pi over 6 is 1/2 pi over 6 plus the cosine of pi over 6. So I get pi over 12. Cosine of pi over 6 is radical 3 over 2. Is y of pi over 6. Y of 5 pi over 6 is going to be a half times 5 pi over 6 plus the cosine of 5 pi over 6. This is equal to 5 pi over 12. This is going to be radical 3 over 2 again, but this case is in the second quadrant, so cosine is negative. So that's y of 5 pi over 6. So we just need to create the equation of our two horizontal tangents, nice line. When x equals pi over 6, our y value is pi over 12 plus radical 3 over 2, and our slope is 0. So it's y minus the quantity pi over 12 plus radical 3 over 2 equals 0 times x minus pi over 6. 0 times this goes away, and let's just move this over without distributing the negative. Just make this positive and move it over. Our first horizontal tangent is pi over 12 plus radical 3 over 2. Likewise, when x is 5 pi over 6, our y value is 5 pi over 12 minus radical 3 over 2. Our slope value is still 0 because we're dealing with horizontal tangents. So we get y minus the quantity 5 pi over 6 minus radical 3 over 2 equals 0 times x minus 5 pi over 6. This goes away, move that over, and there's the equation of your horizontal tangent.